All right. So first up, we have Jason Lee, light intensity comparison between solar emitting diodes and cheaper alternatives for reading in developing countries. No idea. I'll hand over the mic to you.
Do we start?
Okay. All right. Hi, everybody. Welcome to our second annual Middle School Research and Innovation Showcase. Due to some unforeseen events and unfortunately still COVID stuff, we had a few people last minute who were unable to join us, which is unfortunate. So we've also just converted it into a recording as well because some people have asked for that. And so this is being live streamed and it will be available to view after. Really appreciate those of you who are here, both in the audience and who are presenting. I know that you were expecting to be, in a group of about almost 20 people presenting. It will be a much shorter evening than we thought. I don't think anybody will mind getting out early though, so hopefully that's okay. And our research and innovation program at DE involves a variety of things, including robotics, which this isn't really focusing on that because we had a separate showcase in the fall, but robotics, we have science fair research, we have Rube Goldberg Club, we had Science Olympiad and Science Bowl. And I feel like I'm missing a bunch of different things here at Cubes in Space. So we have a variety of ways that students can do really their own project as they choose. So here today we have 5 or maybe 6 students who are going to be spotlighting their work. We're going to start with Jason Lee. Is that tall enough? Or are you gonna go taller?
Hello. Okay. Is this close enough? Okay. So hi, and then my presentation is about light intensity comparison between solar emitting diodes and cheaper alternatives for reading developing countries. So little background information. So first I went to Kenya to donate baseball equipment and I really liked it and I want to do more stuff. So what I did was translate Korean books and then send them solar powered LEDs to them in reusable plastic. So I researched cheaper, never mind, sorry. So after making the LED lights last summer, I wanted to see if there could be cheaper alternatives because as you know, solar power or solar panels and batteries and all that isn't that cheap. I want to see if it could like help more people because obviously it's cheaper, it can help. But I had like a lot of questions like LED, would it like be bright enough or like cause eye strain? How can I make the light cheaper? Like would the glow in the dark stickers be bright enough to read? How long does the glow in the dark stickers or things like stay bright? And how do you measure brightness? And I researched and found out LEDs are connected to a power source, so they're electric. The glow sticks that I measured were chemiluminescent, so it's caused by a chemical reaction. And the glow in the dark tape is phosphorescent, so they contain phosphorus and it gives off light after being energized. So looked up the recommended reading brightness and also measured my room light and desk lamp. And I figured out that the recommended reading is 450, and which is surprising because my room ceiling light is much lower, and that's what I usually use to read. And then one lux is 1 lumen per square meter. All right. So based on all my research, I came up with the following research question, a hypothesis. My research question is, are LED lights worth the money compared to other products such as glow sticks or glow in the dark tape? And my hypothesis is if we make the cost of the LED, glow sticks and glow in the dark tape the same, The LED will emit the most amount of lumens. I mean the lux, which means it will be the most cost effective. All right, so I measured light using the light meter in the picture, and my control group was the iPhone flashlight because that stays consistent. And if the levels were like getting majority different, then I would know the measuring meter would be wrong. And then my variables were, so independent variable is amount of time that passed after a light source was turned on. And the dependent variable is the brightness of the light sources. Constants are things like measuring tool use, time between measurements, which was a minute, and distance from light source, which is 12.25 inch. So for procedure, what I did was first I calculated the same price for LED, glow sticks, and glow in the dark tape, and leave the solar panels like LED solar panel, glow in the dark tape in the sun to charge, and then put the three in 3 different dark boxes. And I also made sure the distance from light source measuring position is close as possible, and I measured light intensity over time. So for cost calculation, it's on the screen. I try to make them as similar as possible for cost. It did not include like build cost, tax, shipping. And there was about a 45-cent difference because I can't cut glow sticks in half and make them function. So those are my 3 graphs that I got. All of them are measured in lux. As you can see, LED was the most consistent bright, but it wasn't really that bright. It was like 0.3. And then eventually goes down 0.2 after 10.5 hours, but like that's a pretty long time. So I would say it's pretty consistent. Glow sticks, there was a point where it got like brighter in the middle in the graph. That's probably because I thought it was errors or something, but it's probably because I took multiple glow sticks and shook them and put it in and snap. But there could have been a chemical reaction that occurred after. Like I was supposed to shake well, but like I might not have shaked them all the same. And then, but I was surprised that the glow sticks were brighter than the LED. And then glow tape was right after it was charged for an hour. It was brighter than the LED, but not as bright as the glow sticks. But the rate of the brightness was decreasing like really fast. Like it was changing every second, even though I measured every minute. So the results did not support my hypothesis as the glow sticks and glow tape were both brighter. And I was surprised that the recommended light level was much higher than the 3 I measured. Like I expected it to be around 85, which is my room light, but it was 0.3, which is really low. And it means that the lights I sent are probably not sufficient. And I needed light sources to reach it, recommended light level to see if I supported them. Like how much of the light source would I need to reach that specific level? So, which is my reason for the next experiment, which you'll see on the next slide. But for my error analysis, like I can't control the amount of sunlight. Like day 2 was a bit cloudier than the first day I measured. I measured a distance of 12.25 inches, but I couldn't really do that with the tape because there wasn't enough area in the box. So there was a bit on the walls. For glow sticks, chemical reactions may have differed based on what the force I snapped them, I shook them, also temperature. It's chemical reaction, so it's really sensitive. And there's also human error, and then also 45 cents different. So second experiment, because all my light sources did not reach the recommended read light level, I did a second experiment to see how many LEDs or glow sticks it would take to reach it, and then find out which would be most cost effective. But I did not include glow tape, which because the rate of the brightness dropped fast, really, and a lot and really fast. So hypothesis is if we make like enough LEDs and glow sticks together to create the amount for the recommended reading light level, the LEDs will be cheaper compared to glow sticks. If we keep adding LEDs and we'll keep adding LEDs and glow sticks to see how much you would need to reach it. the levels for reading, but glow sticks are one-time use, so we would need many more to do the experiment compared to LEDs, which are reusable. So using the data I got, I created a scatter point graph and then graph the linear graph on Desmos. And I found that I would need 1,956 LEDs, which is 3,308 grams. This does not include battery holders, circuit board, and stuff like that. And for glow sticks, I need 242, and then I would need, it was 5,917 grams. All right. So in order to use minimum number of batteries and to achieve maximum brightness, I'll be connecting LEDs in a parallel circuit because I'm using a pre-wired LED diode from Amazon. If I put them in a series, I will be like doubling up the resistors. So it's parallel circuits are made up of branches. So the current divides and the only part of the current like flows through any branch. So I would have to calculate the individual current for each LED and then the total for the whole current. So on the LED package, it says C/V is 20 milliamps and 3 to 12 volts, which means that the LED will be lit when received between 3 to 12 volts, meaning that 3 volts or like something a little less than that is the forward voltage. So the forward voltage is the minimum voltage required to turn it on. The forward voltage is the amount of voltage you need to get the current to flow across the LED diode. And the voltage across the LED will be never be higher than that forward voltage. And at the highest supply level of 12 volts, circuit will draw 20 milliamps, which is the max rating for the LED. And then, so I'll explain the two laws. Kirchhoff's second law, in the voltage law, he states that sum of all voltages around any closed loop in a circuit is 0. And Ohm's law states that it's a relationship between voltage, current, and resistance. So voltage is current times resistance. So using these, I will calculate how many branches need in the parallel circuit. So here's a bit of math. We know that resistance of LED is 560 ohms. Voltage is 3 volts from the battery. And using Ohm's law, which is volt, is resistance times current. We get individual current is 3/560 ampere an hour. And because there are 1,956 LEDs needed, it is 5,868 over 560 is the total current, which is about 10.47 ampere an hour. And total resistance is 0.28 using the same equation. 1.5 volt battery that I was using is 100,300 milliampere an hour, which is 2.6 ampere an hour if we include two of the batteries which I was using. So we get the equation 2.6x has to be larger than 10.47, where x is the smallest integer possible, and we get x equals 5. So 5 circuits I would need to make. Again, results did not support hypothesis because the LED turned out to be more expensive when both were at a recommended light level for reading, but this not considering the fact that LEDs are reusable, so they will become a better price option at a certain point. I assume that the increase would be similar when calculating how many LEDs and glow sticks would be needed to reach the recommended light level for reading. And measuring the weight is subject to human error. And what I mean by the first one is that it could have been an exponential increase, but I used the data points and assumed a linear increase. So I assumed the direct proportion. I might not have purchased the most cost-efficient products as I depended on shipping dates and availability when purchasing. So I did a third experiment because both my hypotheses weren't supported, and I was unsure about LEDs and glow sticks because like 1.9K LEDs is a lot. So I went back and questioned a lot of things like the recommended reading light level. While I found out that 1 lumen equals 1 lux, lumens are the measure of all light from the light source, while lux is the surface intensity, and where the area over the light is dispersed should be considered. Some of my teachers said laser pointer will be bright, but it will not spread enough to be worthwhile for reading. So it'll have a high amount of lumens, but a low amount of lux. And many people use book lights to read. So I looked at over 10 different products, the brightest and least brightest and brightest in my dark box to check brightness. Because if I knew that if I measured the LED, the book light, and then I checked the brightness, it's lower than the recommended reading light level, then I could just do that, as I knew 1,956 LEDs wouldn't be cost efficient. So I measured it the same way I used the glow sticks, LEDs, and glow tape. So hypothesis for this third experiment is if book light intensity does not reach recommended light level, it will not reach recommended light level for reading, and I should use the book light intensity to replace the previous recommended reading level value. And I found that the average lux of my least brightest and brightest book light was just my room light. So I redid my calculations using 85 instead of 450, and you get what's on the board. All right, next one. So pictures show initial prototypes I try to make with each light source on top right corner. And no, in conclusion, glow sticks are better buy than LEDs if we're only using it once. But if it's a light source, you're going to have to use it multiple times. So the LED will be worth it after a certain amount of use. This project could help research alternative light sources that do not require use of electricity, like I researched chemiluminescent and phosphorescent light sources. Research reusable glow sticks, because the big downside to glow sticks are that they're single use and create a lot of waste, and bring the cost down when sending reading light sources to other developing countries like Africa, and raise awareness for the need of reading lights, because reading is an important part of our life. There are over 1 billion people in the world who do not have access to stable electricity, but many people just take lights as a basic thing without knowing how much harder life would be without them. And from this research, I learned that LED is the most consistent and reliable source of light. Glow sticks are not sustainable as they create a lot of waste, and glow in the dark tape requires a lot of light source in order to be charged. And for further research, I would survey to find out preferred light intensity, because everyone's eyesight differs slightly. Look for other organizations like the ones I found that are sending reading lights to developing countries as well, and see how they're doing it, and calculate how long it will take for the solar charge investment to be worth it, which is kind of like comparing gas cars and hybrid cars and seeing when it will be worth the cost. And yeah, one thing I learned is never give up, because this required a lot of patience and perseverance. And references are right there. And top right corner is example, because I used so many glow sticks in the experiment, I had a lot of waste. So I decided to put reflective tape on them and I'm using them for like a safety when like walking at night, so people can stay safe. And I would like to like do something where I could hand out the glow tape, glow stick stuff. Yeah. Thank you.
Thank you so much, Jason. Oh, echoey. Sorry about that, but we do have some questions. I'm getting feedback this way, so I'm going to unmute Mr. Shaw, who had a question.
I was curious to know if you had calculated exactly what the break-even point was for after how much time of illumination does the LEDs become more economical than the glow sticks? I would imagine since the glow sticks aren't reusable, as soon as you have to throw them out, maybe that's the point at which the LEDs become more economical. But
yeah, I would have to consider many things. Like glow sticks are in a single wrap like piece of paper. They have individual packaging, so it creates a lot of plastic. So I have to consider the amount of waste it creates. Plus, I think LEDs it was in my further research thing. But I believe that I probably hypothesize the LEDs will become worth it pretty soon because it's a sustainable thing and you can reuse it multiple times. And for some people, the value of a light source is really important. Any more questions? Oh, for LEDs, I actually have a, hang on. Oh, so they asked how big the LED is. I'll actually get a prototype. I actually brought them here. Pretty small one. It's pretty small. It's in the box. Like it's pretty tiny. Like it's like about this big. So yeah, it didn't generate much. It would probably like a couple light bulbs, like probably one of the big light bulbs. Miss Anderson, do you have a question?
Hi, Jason. Nice job. I was just wondering what inspired you to do this experiment in the first place.
Oh, so what inspired me is that I mentioned before I went to donate baseball equipment, and after that, I donated the LED solar lights, and so I wanted to. I wanted to help more people. Like I want to see, because if I found a cheaper way, then I would probably be able to help more people. And I just wanted to, because then if the more people that have a light source and can read, the better.
Yeah, makes sense. Thank you.
Philip?
Has anyone ever created like an LED or like any like small light source that can reach like the 450?
He asked if there's a small light source like the LED that could reach the light level. I'm not sure, but I'm pretty sure it's gonna be hard for something as small as that to reach that. Like my LED, it probably had a high amount of lumens because it was kind of similar to a laser pointer, but it's gonna be like hard to have something as small as that emit a lot of lumens, because that's around like desk lamp. Ms. Shaw, do you have another question?
Sure. There are actually ultra bright LEDs, and some LEDs have different forward voltage ratings than others. So I was wondering if you had considered alternative types of LEDs. I realize that's similar to the question that Philip just asked.
Yeah, I did consider alternate light sources, but I wanted to compare something each category, like fluorescent, chemiluminescent, and electric. As I said, I did not, as some might not have been the most cost efficient because I depended on availability and shipping rates. But if I do something like a further research, because there are many LED lights like that, I would probably see which one would be most cost efficient, because there are like some ultra lights like that.
All right, thank you so much, Jason. Our next presenter is Andre Valencia, who did some work with, last year he sent some strawberries into space for the Cubes in Space program. And this year he did some analysis on those strawberries that went to space. So if you want to come up here and join us, Andre.
Okay, so my presentation is about the effects of UV radiation on the germination of strawberry seeds. So my project goal was to answer the question of whether or not the amount of ultraviolet radiation experienced in a near space environment would allow strawberry seeds to reliably germinate, or if it would hamper the germination, and compare and contrast the seed's rate of growth with a set of seeds not exposed to radiation and a seed set not exposed to air. I use seeds flown via the iDoodle EDU Cubes in Space program on a NASA operated balloon, as well as ones not flown that were bought in the same time period. So they were all the same age. I also tested control seeds that were not exposed to air. The effects of many other types of radiation have already been tested on other seed types, but UV radiation's effects haven't been tested as well. My research question was, is the rate of germination of a strawberry seed significantly affected by exposure to the level of UV radiation found in a near space environment? And if it's also affected significantly by the exposure of the strawberry and its seeds to air? My hypothesis was that if seeds are exposed to UV radiation, they will germinate generally more slowly, and some won't germinate. If they aren't exposed to air, their growth will be the fastest and the most will germinate. If the seeds are exposed to air but not radiation, they'll be in between the others in terms of both categories. So my control variables were the age, the germinating conditions, and the species for all three. Two of them were exposed to air, and of those, one of them was exposed to UV radiation. My independent variables were exposure to air and exposure to UV radiation. My dependent variables were my rate of germination and how many of my seeds germinated. The UV exposed strawberries were flown on a high altitude research balloon last year as part of the Cubes in Space program. They were exposed to heightened amounts of UV radiation due to being practically outside the atmosphere. Then they were shipped back to the school and they sat until I started my project. To germinate the seeds quickly, I researched online seed germination advice and methods. I ended up placing them in moist paper towels, briefly freezing them, and then extracting the seeds and leaving them in the Ziploc bags to absorb light on a windowsill. So these were the results I got. 9 days and 10 days, 9 days, 10 days, and 11 days respectively after starting. And as you can see, the UV exposed ones initially didn't germinate at all. And the air exposed ones had the highest rate of germination. And the ones that weren't exposed really were mostly about the same, but a little lower. After analyzing my data, it appears that the seeds not exposed to radiation tended to germinate more quickly and in greater numbers. 60% of the seeds were germinated by day 10, and the radiation exposed seeds germinated in the smallest quantities. This work is important because due to climate change and production of ozone depleting substances, the amount of UV radiation that reaches the earth will most likely increase in the next 50 years with the decline of the ozone layer. It is important to know the effects that this may have before it starts to happen. It will also help with knowing the long-term effects that space settlement will have on organisms and evaluating the best types of plants to cultivate on long space flights. In conclusion, based on the results of this experiment, part of my hypothesis is shown to be true, with a smaller percentage of seeds germinating from the UV exposed samples than from the other two sets of samples. This shows that an excessive amount of exposure to UV radiation may inhibit germination in strawberry seeds. Questions? Questions?
I do have a question. Your assumption that your one of the factors in affecting germination is exposure to UV radiation. But could there be other things that affected those seeds besides exposure to radiation when they went up into the balloon?
I suppose they could have been, but they were mostly kept sealed in a plastic cube for over about a year, and the control seeds were also kept sealed for that same amount of time. So there was practically no change in their environments.
But is it possible that the change in atmospheric pressure could have had an effect on them, and the UV radiation exposure may not necessarily be the cause in the change of germination?
I suppose so, but the cubes are pretty much they're quite tightly sealed, and besides the seeds not exposed to air were also vacuum sealed, and they didn't have similar results. So this evidence indicates that it was probably the exposure to UV radiation.
Gotcha. Thank you very much.
Yeah. She was asking if I picked strawberry seeds or if it was from the project last year. So last year we used strawberries for completely different reasons, which was mainly because they had more DNA than most other plants. But this year I had to work with the strawberries. And if I had been able to do this experiment from scratch, then I probably would have chosen something that isn't as finicky when germinating and germinates more quickly. Any other questions? Okay.
Great. So next we have Philip Levinsky. His project is a little bit different. So far the two people that we've seen, those were for science fair projects. Philip is actually going to present a project that he did for several projects that he did in physical computing and in Science Olympiad. So he has a little bit of a different format, but also very interesting about the iterative design process. And Andre, if you could just stop sharing screen.
All right. So as Ms. Lernoff said before, I'm going to be doing a bit different of a presentation. So I'm going to be talking about how I made this little car here and how down there you can see it's called a mousetrap car, and big credit to like Jason, Leo, and Andre, and like all the people that made it and everything. So first I'm just going to talk about this car, and so some challenges with building a car. So you might think that it's easy, but it's actually harder than you would expect, especially for a motorized car. Like recently we saw in Cars and Trucks and Things That Go, I think it was, they were using CO2 propelled cars along a track. This is using a geared motor to turn wheels. So first I'm just going to talk a bit about circuitry. And so the basics of circuitry. So let's say you had two wires connected. You had a light bulb and a battery. So one wire would be connected from the battery to the light bulb, and then the other wire would be connected from the light bulb back to the battery. So the energy would flow through the entire thing, and it would go around, and the light bulb will light up. Now, the problem with this is that I can't turn the light bulb off, so the battery will just like go out eventually. So what I will want to do is I want to add a switch. And basically what a switch is you might be able to see it here. It's right there by my thumb. What a switch is, it stops the electrical current and it keeps it going again. Basically, so I can show here. So currently the switch is off, and when I touch it on, the wheels start moving. And this is only because before this, the inside the switch, two metal pieces were not touching each other, and so the electricity was not flowing through. Once I flipped the switch, those two parts came together and it went through. So yeah, that's the basic of switches. So now I'm going to talk about how I made this. So first, I don't know if you're able to exactly see this, but I needed to take these motors. Here, let me. All right, so first I needed to take these two yellow motors, and they're on the bottom right here. Oh, thank you, Ms. Larnoff. Yeah, so these two yellow motors right here, and I had to attach them to wheels. And the really nice thing about these motors and these wheels is that there's actually a little shaft right here. Yeah, right there. Oh, there's a little shaft right here where you can connect these type of wheels perfectly. And so that enables it to turn. So when the motor switch on, the wheels turn. So in order to connect the circuitry, what I had to do is I had to take a wire from, so first we have the battery that's up here. It's right there. Yeah, right there. And so basically how so there are already two pre-made wires connected from the battery. So what I did is I took those two wires and I took two more wires from the motors to those wires. So there would be electricity going to each motor. Now, how did I connect those wires? It's not like Lego, so there's no like complete connecting. So I had to do something called soldering, and a lot of you might know this, but soldering is where you take a soldering iron, which is a really hot piece of metal, and you take solder, which is this liquid. Oh, it's this metal, and when you heat it up using the soldering iron, then it becomes liquefied, and you can put it on and connect two pieces of wires or metal. And the good thing about solder is that it can conduct electricity. That's why we use it to connect wires. So that's what I did for the wires, and I soldered the wire to the motors. So after that, I took two more wires, and you can see them right there. And I took those two wires and I soldered them onto each motor, and I connected them to the switch. So now since everything is connected, so I have one wire going to the motor, another wire going to switch, one wire going from the switch to the motor, and one wire from that motor going back to the battery. So everything can circulate. So when I click the switch, the wheels turn. So I'm just gonna show it go. Miss Larnoff, can you like angle the camera down? Thank you. All right, so currently the switch, it's not on, but when I press the switch, it moves. So pretty cool. And I'm just going to talk about one other problem with creating a car. Oh, yeah, thank you. So one other problem with creating a car is, so you could put, like in shopping carts, there are wheels at the bottom and they can turn around so you can go in either direction. But we wanted to make a car that was stable and went as straight as possible for the challenge that we were doing in our class. So I wanted to use 4 wheels. I'll also credit to Chelsea because she was my partner and she helped me out a ton on this. So what we did is we need to make a shaft like in our cars. So the problem with this is there's no easy way to install a shaft. There are a few different ways. What we did is we took 2 blocks of wood and we hot glued them onto the bottom, as you can see right there. And we drilled holes through them so the shaft could go through. And we taped 2 pieces of wood to each wheel and we taped them together. So now the wheel can turn freely. So that was probably the hardest part of this entire thing. So yeah, that's it. And then I'm going to talk about this mousetrap car quickly on how it moves. All right, so the mousetrap car, unlike the previous car, does not use any motors whatsoever. So how it works is we have a mousetrap, and mousetraps, they spring forward when undone. So if I pull this back, it'll go forward like that. So what happens in this is there's a piece of twine wrapped around or taped to this taped to the axle of the mousetrap of the wheels. So when I roll up the wheel, the red twine starts moving back, and then the mousetrap is now suddenly up. So if I let go of the axle, then the mousetrap will go down and the wheels will turn. So that's basically how it's using. It's using the force of the mousetrap, which is a spring. It's automatically trying to go down, and we're taking a piece of wood to and the wood is basically mousetrap is basically winding the wheel to make it go forward. So in action, it looks like this. It might not work very well on the rug because, again, the mousetrap isn't very powerful, so it's hard to get going. But here, let me try. Sorry, that's I wound it up the wrong way. All right, here we go. All right, so it doesn't look very good because it doesn't really work on carpet because the wheels are made out of CD discs and it's really hard to gain traction because the wheels are so small. But that's basically how it works. And again, big thanks to like everyone who made this. So yeah, that's a bit about the mousetrap car and the car that I made. So thank you. Any questions?
Hi, Philip.
Leo.
Mr. Shaw.
Oh.
Can you tell me a little bit about any engineering or any design changes you made to get your cars to go straight?
All right. So first of all, so the car that I have now, so we wanted it. So one thing that we did, so if you might have noticed this, but on one side, there are rubber bands on the car, on the wheels. And so the reason for this is since rubber bands have this like kind of not sticky texture, but this rough texture that can gain traction easily. And so we ended up seeing that the car for some reason was turning to the side of it. This is probably maybe because the motors are the way that we soldered on the wires. So what we decided to do is we decided to add more traction onto one side so it would counter the car from moving. And originally we had a different piece of wood that was a bit too big and a bit too lopsided, so the car would like tip over to one side.
Great, thank you.
Yeah. Oh, Leo. So Leo asked if you had made a truck, what would I need to change to make it move? So I wouldn't say any, probably nothing. You're just going to need to make it bigger and have more powerful motors because again, it's going to be bigger. It's going to be more wheels. But you might need to add an extra set of motors. I'm not exactly sure how many wheels are moving on trucks. but you just need to probably make everything a bit more powerful or bigger. Oh, Miss Anderson? Miss Anderson? Okay.
So Ms. Anderson typed her question. So this was really informative, Philip. You're a good teacher. How did you learn or figure out how to do this? Was it a lot of trial and error, or were you inspired by car models you had seen in the past?
All right. So it was mainly for this car down here, also for the mousetrap car, there was like one before it. I don't there was like a version before it that didn't work, so I had to like scratch it, like destroy the entire thing and restart. But especially for the car right here. So again, I said we had to go through, I think like it was like 2 models. We kept trying to find the base, like make the base a bit different. And we needed to like keep re-gluing on the wheels because they would go in funny positions. So one wheel would be facing one way, and the other wheel would be facing the other way, and then it would go in this weird direction and would go really slow. So we went through a few processes of that, but then it also took a ton of time to solder on everything. Because one time actually, which was probably our biggest learning mistake, is that we forgot to put electrical tape onto the wires. So if you see here where the wires are like connected, there's a piece of tape, and electrical tape is basically just tape that electrical current cannot travel through it. So what happened was we're pretty sure that two of the connections like touched each other. So the electrical current got too small, and therefore the battery almost got fire and started smoking, which is pretty bad. So we ended up having to get a new battery, and we put on electrical tape so that wouldn't happen again. Andre? All right, so Andre just like wanted to point out that we made for the mousetrap car. It's basically like a large scale wind-up car, which yeah, it's true. You're just winding up the axle and making it go. So it's kind of like those toy machines where you wind it up and then it's like the gears move, so it like walks forward and whatnot. All right, thank you so much. Thank you.
Thank you so much, Philip. And now we're going to have the other Philip and then Leo last. There's a few other students also that recorded their presentations, and I will add them to the online webinar, but I think that just in the interest of time tonight, we'll stick with just the live presentations tonight so that people can get home. So Philip H., are you ready?
Yes. Should I turn my camera on or like? Okay, I'll share screen.
Yes, Philip, please turn your camera on.
Oh, okay. Okay. Share and then. So my project is about how I observed the different rates of consumption of polystyrene by the beetle Zoophilus morio. So I have been interested in about different kinds of ways to incorporate, I guess, insects, because insects are a very overlooked group that actually can solve a lot of like world crises, but people are just not looking into them. So I remember a article that I read back in 2019 about how Stanford researchers had a breakthrough where they discovered that several insect larvae, including mealworms, were able to digest styrofoam. This was great because styrofoam took almost 30% of the plastic found in landfills, lakes, and rivers. My hypothesis was that if superworms were exposed to high amount of heat, water, and starch, then they will consume larger quantities of styrofoam in a shorter amount of time. Because heat and the excess nutrition would cause the superworms to be more healthy and increase their metabolism. So back in the question, I said the research article was about mealworms, but why did I choose superworms for this experiment? Because superworms and mealworms are actually two separate things. Superworms are in the genus Zophobus, while mealworms are in the genus Tenebrio. Superworms actually get like several times larger than mealworms. The reason I chose superworms was that they get much larger, as I said, so they consume larger quantities of styrofoam. And superworms are a little bit harder in my experience because I kept superworms before this project. And this would reduce die-off and some variation in the experiment. And the biggest reason, though, I kept superworms was because unlike mealworms, superworms needed to be individualized before pupating. And this is great because we don't want them to pupate, because once they pupate, they will not eat styrofoam for another month. So that completely ruins the experiment. So this is much better in terms of experimentation. So during the course I was doing the experimentation time, I actually had 2 attempts doing this project. My first attempt was actually with mealworms, trying to find what different kinds of plastics that they could eat. And though my final attempt eventually was that I was comparing superworms how fast they could eat styrofoam with different supplements. So this is my first attempt. I did this in school. I tried to determine what kinds of plastics that they could eat, like packaging foam, styrofoam, even like 3D printer material. And I found that this mealworms were visibly eating styrofoam and packaging foam, and they had minimal impact on the 3D printer filament. But I wasn't fully able to get the entirety of the experiment because the control, while I was away under a on a what is it school trip, the control died, and then like 70% of the mealworms of the control died. So I decided to completely scrap this experiment because it wasn't going to give people like accurate results. So, what happened? What happened? Oh, sorry about that. I don't know what happened. So this is my so this is my current project attempt. And so basically so at this point, so I was doing this for the Bergenstein challenge, and I had less than a week left until the deadline, so I had to hurry fast. So I changed the subject from mealworms to superworms, and I changed the setup to improve on the previous experiment's flaws to minimize any die-offs or anything like that. So this is the overview of the experiment. So I added approximately 6-gram portions of styrofoam. I measured them down to the milligrams, and then I put each styrofoam inside a container as well as a thin layer of substrate to prevent desiccation or drowning. And then I put 35 superworms in each container and then set them up in one of 6 ways into, I guess, variables. One was heat, which I put at 70 degrees and 80 degrees. And another was different supplements I had. Either I had nothing inside except the styrofoam and substrate. I added water, or a 1-to-1 mixture of water and potato starch, and I added such supplements on a daily basis. So this was like the final results that I found. So what I found was that unlike my hypothesis, starch actually did not accelerate the process of consumption of styrofoam. Rather, it actually decelerated it. As you could see, starch had this lowest and the second lowest amount of styrofoam. By the way, there's the conditions, the original weight, the final weight, and the difference of weight that I had. And a weird thing is, it is likely due to the small time experiment, was that this wasn't fully 100% accurate, as you could see the water 80 degrees by far had the most styrofoam eaten with 1.1 grams, which is almost twice the second, which is no water 70. But the thing is that these are the two opposite other than like starch, which was weird and was probably due to the like I said, the small amount of time that I had. So these are my that I find interesting and some troubles I had. So like I said, this experiment was supposed to be about how what kind of styrofoams that mealworms are supposed to eat. Unfortunately, that experiment did not go well, so I had to change this experiment and I improved on flaws. Also, an interesting thing I found out about how superworms eat styrofoam is that, and food in general, is that they tend to hollow things out from the inside out, where they could make like large like tunnel systems and like large cavities inside the styrofoam, where they just create rooms and just start eating at the walls, basically. Well, which I think is used to maximize the amount of styrofoam eaten without letting a lot of light in. Like I said, like no water 70 and no water water 80 no water 80 degrees were not in line with the other results, and this could have been caused by a couple factors, which I admit were partially my fault. So this is my conclusion. So in conclusion, superworms show that they're best at higher temperatures, because I kept superworms in a couple different conditions just to get a feel for them, and coupled with this experiment, I concluded that superworms show that they are best at metabolizing at higher temperatures, which is pretty in line with my hypothesis, because a lot of animals require higher temperatures to fully metabolize. And a moderate amount of water to prevent desiccation, and without supplements, because my guessing for this is because the superworm actually prefer the supplement over the styrofoam and start eating that instead. So in 4 days, the 35 superworms averaged around 0.135 grams a day. So if we put that into a large scale project, then at a small site of 1 million superworms in like a large, a massive container, would eat almost 1.4 tons of plastic a year. And under the best environment that I showed them, they could substantially increase the amount of consumption they can by, and I researched this by twice. So while we must try to like decrease the production and our usage and the throwing away of plastic overall, I mean, if we have huge like facilities, I guess that's what I'm imagining in the future of like superworms and mealworms, like a couple hundred facilities around the world, just all eating like the styrofoam. It could potentially be a much greener way of reducing our plastic, because their frass, which is their excrement, after eating styrofoam, is actually biodegradable, and they could be used as plant fertilizer and other such. So some future things to keep in mind is that I would like is to definitely like utilize the time a lot more, because like I said, I had very little time. So I probably will redo this experiment in the future, and I'm gonna allow a lot longer time to study like the more long-term effects that it has on the superworms. Also, I want to go back to the mealworms and different plastics idea. I feel like I could improve on that significantly, and I was actually kind of curious about what they could effectively eat. And another thing to keep in mind is just to maximize like the controlled settings, because even though like they were like basically right next to each other, there was like a couple degrees difference between, and that might have affected it. So these are my glossary links, and I am finished. Thank you for listening.
Philip, I have a quick question. First of all, this is really, really cool. I had no idea that insects could digest plastics. I never knew that. One question that I had was, insect larvae are food sources, pretty low down in the food chain for animals like birds and things like that.
Yes.
And this is obviously beyond the scope of the research that you did, but I wonder if any of the reading helped you understand whether or not the chemicals that make up the plastics become part of the mealworm or the superworm, and then what might be the impact on animals higher up in the food chain. Would they be ingesting any of that plastic? Or if you were doing like a large scale superworm styrofoam digesting project, would you have to somehow sequester those worms so that they don't end up in the food chain?
So I actually did some research into this. So the superworms are still entirely edible because polystyrene, what it basically is a chain of a bunch of different molecules. So basically, so mealworms and superworms and other insect larvae have gut bacteria, and that completely breaks down and then repurposes those nutrients. So it wouldn't taste good because like their frass wouldn't taste good, but like it is technically edible, so it wouldn't affect the food chain that much, from what I've researched.
And Miss Kim has a question. Miss Kim, if you want to ask your question.
Hello?
Yep, we hear you.
Oh, hi, thanks. Phil, that was a really awesome project, an experiment. I was actually curious, and this is mostly like Mr. Shaw was asking, kind of maybe like a research question, but were you able to find out how sustainable it is to just feed superworms styrofoam? Because it seems like when you added supplements, they weren't eating as much. So I wondered if a 100% styrofoam diet is sustainable enough to keep superworms just to eat styrofoams alone.
So like there was an article that said that it's not 100% sustainable to just feed styrofoam, but it is there is some like efficiencies to spare with superworms just to give them a little bit of enough supplement to fully live out their lives normally. Because this happens in a very long-term scale, so it doesn't it's not that important, but it should be I guess measured.
So actually, so my second part of the question is, so would it be more beneficial? No, would it be more cost effective to have superworms that eat a lot of styrofoam and die early, or do you think that it would be more cost efficient to just give them a little bit of a supplement so they can live longer and eat a little bit of styrofoam?
I mean, like, I feel like it's rather cost efficient just to give them the supplement, because the supplements can be literally anything, I guess, bio or like organic, because like I guess like excess food waste that could be used as supplement for the superworms. So they would actually knock out two birds with one stone. Like it would just act like the compost machine that also like digests styrofoam. So this would really have like not a lot of economic like what significance, I guess.
Okay, great. Thank you so much. That was awesome.
Thank you.
Any other questions for Philip? No, but I will admit that I am the another person whose care the mealworms were in when they died. Although I think I followed his instructions, but I guess I am not as good at caring for mealworms as Philip is. So I do apologize profusely for killing his first experiment. All right, Andre, you ready? Not Andre, sorry, Leo. Yep, you can share your screen. You want to do it? by a coincidence, actually, everybody who presented here was also involved in both, I think, the mousetrap and what Leo's going to show. Oh, Andre was not a mousetrap.
Sorry about this. Jason's just pulling up the slides right now.
All right, so I'm gonna share our innovation project from our, okay. So I'm gonna share our innovation project from our robotics team. And I know many of you guys have heard this before, but for people online that haven't heard about this, I'm just gonna share about, so just to give you a little bit of a background, every year for the first Lego League, we have different parts to the competition. One of the parts is the innovation project part, which is basically a competition where you're trying to innovate and create something that helps solve a problem. And every year there's a different topic. And this year it was called Cargo Connect, which basically is a topic where we're trying to talk about transportation and cargo. So basically our project was that we wanted to do something related to truck safety. And yeah, so this was our problem statement. And most of us on our innovation team wanted to do something related to truck safety. So we basically came up with this idea and we went with it. And there's other parts to the first Lego League competition, but that's kind of like irrelevant right now. So I guess we'll just start with our innovation project. Wait, can you go back? All right, so our problem statement was that in the aftermath of like a truck car accident, people are like very quick to assume that it's the truck's fault because of the accident, but this isn't always the case. And we have to remind everyone that truck safety is an important issue, and we have to educate and remind car drivers the importance of truck safety. And this was our problem statement, and we wanted to create a solution to help solve it. Okay, so basically we had some initial ideas. We made a Padlet and we brainstormed like some possible problem solutions and impacts. And as you can see, we had like 10 to 15 different ideas that we could have done. And many of these ideas, some were like a bit too far-fetched that we thought. So we decided to go with a PSA idea, which is basically a public service announcement. And out of all these, we thought that it was the most realistic and impactful idea that we could do and finish in time for the competition. So those were like our initial ideas. So our solution statement was that we created a public service announcement video to highlight the challenges that truck drivers face daily. And the public service announcement is used to remind car drivers to act safely around trucks, as trucks have many obstacles and aren't easy to operate. The public service announcement is also it actually features many two truck drivers actually, and to elevate their voices. And then we also we sent it to like different radio stations, and we also created some course materials for like drivers ed classes to further educate them about truck safety. So for research, we first looked at like the impact of about truck safety. And as you can see, truck safety is just a really important issue. Like every time you're driving on a road, for example, you usually try to like watch out for trucks because you think they're like really dangerous. And as you can see by the statistics, we see that almost like 500,000 people are in some sort of like accident every year, and this was in 2019. And it's detrimental because many trucks, since they're like a lot heavier, they create like a bigger impact, and this number increases like every year. And there's been a 52% increase in deaths compared to 2009, which is not a good number, because if we keep on increasing this number, we will keep getting more accidents and more fatal crashes. But one of the main problems is that car drivers aren't aware that the problems that truck drivers experience. So they're like quick to assume that the truck drivers are like usually lazy or they don't like pay attention. But this isn't really the case, because whenever like there's a truck car collision, because trucks have like more obstacles than cars, and it's much harder to operate. So we wanted to give this issue more awareness, and before we could like see more fatal crashes and more accidents. So for some background research, we talked to Mr. Pekis, and we talked about research about this issue, and we learned about information on websites and information on how to use keywords to further advance our research. And we did this based on online, where it's just like in the web, government websites, and our school has like a private research library and called ProQuest. And we also talked to experts, and we talked in Zoom to them, and we learned from them and record them. And we got most of this information to further help us with our research and make a more accurate public service announcement that we would like show to the public. So we had like many ideas for our public service announcement. I think we went through like 2 to 3 weeks just like brainstorming what we wanted to put in our public service announcement. And this is just like a screenshot of some of the ideas that we wanted to put in our public service announcement. For example, like trucks take longer to stop, trucks rear mirrors operate differently, trucks are slower in general as they weigh heavier, and trucks accidents mostly happen at night. So those were just some of like the issues that we wanted to highlight in our public service announcement. And for like this is another part of like the competition, but we used it to help with our innovation project, because we thought it was a good idea to invite experts to come to a webinar, and it especially in like the field of cargo and transportation. And many people came to watch and learn. Like now I think it's like more than 500 views already. And it was kind of like we learned the core root of our innovation project, and we learned a lot from it, and so did many other people that came to the webinar. So these were just a list of some experts that we talked to and were in the webinar. And as you can see, they're all advanced people in their field, and we learned a lot from them. So we have to give a lot of credit to them. So then after we got all this information, we had to start work with experts in our own school. And like the bottom two, Tony Rainey and Camilla Johnson, are experienced truck drivers. So these are just like a list of some teachers that we talked to. And as you can see, they all contributed in some way. And they gave us a lot of good tips that we further used to advance our public service announcement to become like the best it could be. And over like a lot of time, we finally started to create the final product. And this was kind of like our process that we went through. And we actually didn't do this in like a long period of time. I think we did it in like during one tag. And we basically just finalized the script, and then we started to record our experts, and we recorded our voices, and then we kind of edited it with the help of Mr. Klementowski, and we basically edited the entire video, and we also gave it to the faculty for feedback, and then we improved our video. So we had kind of like 3 final products. The first one is obviously the public service announcement, which we used to we put it on YouTube, we put on social media platforms, and we basically we also sent it to like truck drivers and high school students. And we basically just wanted this video to go as public as possible so we could share it to as many people who could become more safe and more educated on this issue. And we also created the radio public service announcement where we sent like a shortened version to the radio, which they could play on their radio stations. And we also created drivers ed resources, which is a bit longer. And it was like a slideshow presentation with voiceover. And this we shared to drivers ed teachers. So all these 3 final products were made to educate people about truck safety and how they could avoid it. So we sent a survey out to the entire grade, and these were our results. And as you see on the left, we see that most people knew that there was like some sort of risk when they were like near trucks. And now, like after they watched the video, as you can see, basically like 2/3 of the entire like people that responded said that they learned something new from the video, which was good. So our impact is to remind more people on the importance of driving around trucks safely. And we gave tips in the video how to do so. And then we helped people change their perspectives on car truck accidents, and we spread awareness over this issue. And our ultimate goal is to save lives, and we hope that there will be less truck car accidents, meaning less fatal crashes in the world. And even though that is like an ambitious goal, we hope that even like a public service announcement can help strive to achieve this goal. And we hope that you guys learned a lot from the innovation project. So this is our public service announcement.
You might think you know how to drive around a truck. You might be wrong. Did you know in car-truck accidents, it's actually the car driver at fault 80% of the time?
I believe that every state should implement anyone that drives a vehicle to listen and watch video on trucking.
Did you know if you cannot see the side view mirror of a truck, you are in the truck's blind spot?
If you're directly behind a semi truck and they have a trailer, if you cannot see the side mirrors on that truck, you're probably a little too close.
Did you know trucks and buses are up to 30 times heavier than cars and therefore take much longer to stop?
I always say it's not my driving that scares me, it's everyone else around me.
Don't treat cars and trucks the same. Keep a safe distance.
Yield to trucks. Save lives.
This public service announcement is brought to you by Dwight Englewood Middle School Robotics Team Supernova.
So that's our public service announcement. And I also wanted to add, after the competition, me and Mr. Enough created a
you might think you know how to drive
called like an Instructable, I think. And basically what an Instructable is that it's kind of like a description of how to like create a project that we did and we posted it on the Instructable platform so we could educate more people and encourage more people to create more projects like this that we did for our innovation project. And we also submitted this project to the New Jersey Design Thinking Competition, and we got an honorable mention for that. And our project also won first place in the innovation in our like judging pod, which is a nice accomplishment. So yeah.
Hi, Leo, it's Mr. Shaw. Can you tell me what was the best piece of feedback you got when you were showing your video to other people during the revision process?
So I think one piece of useful feedback that we received was about I think like the 2/3 I think pie graph, and we had like many teachers tell us that they thought it was more useful, which was good because we went through over like I think like a dozen different scripts, and every time we try to like improve it. So we were happy that in the end we could get a final script that would help teach more people about driving safely around trucks.
Thank you.
All right.
All right, thank you so much. And thank you everybody for coming and everybody who watched at home. I know there was a little bit of last minute changing and some people who couldn't participate, and hopefully we'll find some way for them to record videos of their presentation so it can be included. And thank you to everybody who stayed here. And I'm sure that everybody appreciates you staying to the end so that everybody had an audience in person and online. And congratulations, everybody. I think you guys did an amazing job, and we'll see you tomorrow at school.